we have seen our discussions on parser design. So, in the next few classes, so what we will do is that we will take a few examples and try to solve them, because this particular chapter it requires lot of practicing, as I told you. And you must have also noticed that calculation of these individual parameters, individual sets is often a bit cumbersome. So, I would like that you also do the practices, so that you can be quite confident about it. So, to start with, we will solve a few problems. So, first we solve one problem which is from predictive parsing. So, in this problem we try to see whether a given grammar is whether a given grammar we can have this thing, whether the grammar is LL1 or not. So, the question is the grammar LL1. So, the way to answer this question definitely is to try to construct the LL1 parsing table and see whether there is any duplicate entry in any of the cells of the table. So, the grammar given is like this: E producing E dot I within bracket E, where this dot I, then open parenthesis, close parenthesis, they are all terminal symbols of the grammar, and E is the non terminal symbol within bracket E, or E question mark E colon or I. So, here this dot, this I, question mark, colon. So, these are all terminal symbols of the grammar. Now, you see that this grammar, to check for LL1, the first obstacle that we have here is that the grammar is left recursive. So, E producing, so you have got this E at the right hand side again. So, first job to do is to eliminate left recursion. The first step for solving this problem is to eliminate left recursion. So, how do we do this? So, there is a set of rules that I have discussed previously. So, if you apply those rules, then it will turn out to be a grammar like this: E producing within bracket E and then E dash, or I E dash. So, the rules for which immediate left recursion does not appear. So, for they are to be taken, and this E dash is a new non terminal that has been introduced, and now E dash can be made to produce dot I within bracket E dash, or question mark E colon then E dash, okay, or epsilon. So, this is the grammar that you get after eliminating the left recursion. So, the next step is to compute the first and follow sets, because we try to get the predictive parsing table. So, the next step is to get the first and follow set. So, we have got two non terminals. So, I should have two first sets, first of E and first of E dash. So, first of E, so starting with E, you can understand that it will have the symbol open parenthesis and I. Okay. So, this is the first set. Similarly, first of E dash, it has got dot and then this question mark. So, this is there in the first of E dash. Now, the follow set, follow of E and follow of E dash. So, this is to be computed. Now, follow of E. So, if you look into the grammar, so we have got this close parenthesis, because in this rule it is ending with after E you get a close parenthesis, and also if you look into this rule, you see the colon can come after E, and this so whatever so then whatever is in first of E dash is in follow of E. So, by the because whatever is in, so if you look into say this rule, so E producing I E dash. So, whatever is in follow of E will be in follow of E dash, and then this one follow of E dash, you can see that follow of E dash will be equal to follow of E. So, that way, so by this rule, say E producing I E dash. So, E producing I E dash. So, whatever is in follow of E is also in follow of E dash. So, that way follow of E already I have got this close parenthesis and colon. So, these two will be there, and E dash being the start symbol of the grammar. So, dollar will be there in the set. Okay. And also, if so this from this rule, E producing E within bracket E and then E dash. So, this dollar will also come in the follow set of E. So, then this if you try to construct the table, the parsing table, then it will be like this. So, then we have got the symbols dot I, then open parenthesis, close parenthesis, then question mark, colon and dollar. Okay. Now, this so this so by the rules that we have for constructing the predictive parsing table. So, it says that if there is a rule like A producing alpha, then and for, so you have to look into the first of alpha, and for all those first of alpha, all those symbols I have to add A producing alpha into the set. So, if you look into the first rule E producing within bracket E etcetera, then the first, so this is the alpha part, this part is the alpha part. So, the first of it contains the open parenthesis. So, this open parenthesis, so I will add the rule E producing within bracket E, then E dash. So, this rule will be added. Similarly, when it is applied on the second rule E producing I E dash, so this will be added here, because I have got I as the start symbol of the I as the I in the first of this I E dash. So, this will be there. Then for the third rule, it says that E dash producing dot I etcetera. So, in the dot I should have this rule added. So, E dash producing dot I within bracket E, then E dash, this will be there, and then this now you see there is a rule like E dash producing epsilon. So, there was another rule that if first of alpha contains epsilon. So, if there is a rule such that A producing alpha and first of alpha has got epsilon in it, then I have to add this A producing, I have to add this A producing alpha to all the places in the follow of A. So, this E dash producing epsilon. So, in that case alpha becomes equal to epsilon. So, first of alpha definitely contains epsilon. So, this E dash producing epsilon has to be added to all the places where we have got this where these follow symbols of E dash are coming. So, follow of E dash contains open close parenthesis, colon and dollar. So, this close parenthesis will have, so I have to have E dash producing epsilon added here, then E dash producing so this colon. So, there also I have to have this E dash producing colon appearing there, and I have to have this E dash producing epsilon added to this one, E dash producing dollar. Now, now if we look into this rule E dash producing dot I. So, this we have already discussed. Now, this rule E dash producing question mark then E colon E dash. So, there the first of this is the alpha, and first of alpha contains this question mark symbol. So, this will be added at this point, that E dash producing question mark E colon E dash. So, this way we can construct this thing, this predictive parsing table. So, in fact, in this follow set, so this dollar should not be there, because dollar since E dash is the start symbol, sorry, dollar is there in the set, because dollar E is the start symbol of the grammar. So, for start symbol of the grammar dollar is there, and as a result from this rule E producing I E dash, whatever is in follow of E is in follow of E dash. So, dollar should also be here. So, this was all right. So, ultimately when we have constructed the parsing table, you see that we have got this in this table there is no entry which is multiply defined. There is no cell in this particular table where we have got more than one rules applied, rules to be noted there. So, these blank entries are all error. So, that is fine, but there is no duplicate entry. So, this grammar is definitely LL1 grammar. So, the grammar is LL1. Okay. So, this way you can solve this particular case that this grammar is LL1. Now, let us look into another grammar and try to see whether that is also LL1 or not. The grammar is like this, that example number 2, question is same, that is the grammar LL1. Okay. And the grammar given is like this: A producing B C x or y, B producing y a or epsilon, C producing a y or x. Okay. So, this grammar we want to see whether it is LL1 or not. So, first thing to check whether there is any left recursion. So, there is no left recursion, because here I have got A producing B C. So, if I substitute this rule also here, so it will not lead to any left recursion. Similarly, here also if I substitute in the place of A B B C, so it will not start with C. So, this is not a left recursive grammar. So, that part is fine. So, we can come to the second step of this problem solving, where we try to see what is the first set and follow set. So, we have to look into, we have to compute these sets, first of A, first of B, first of C, then follow of A, follow of B and follow of C. So, these are the sets that we have to construct. Now, first of A is anything that you can start with A. So, it is we have got this y, and then you can do it like this, that from A can give me y definitely, and then this, if you replace by this B C and then B replaced by epsilon and then C replaced by x. So, as a result x can also come in the first of A. Similarly, first of B you have got y. Okay. So, otherwise so nothing else can come. So, only y can come here, and the first of C. So, since it starts with A, so whatever is in first of A is in first of C. So, I have got these symbols x and y, both of them, and x from the second rule also this x is automatically coming to the first of C. Now, for the follow set. Now, the follow set, since A is the start symbol of the grammar. So, whenever it is not mentioned what is the, which one is the start symbol, the first non-terminal appearing on the left hand side or the first rule. So, that will be taken as the start symbol. So, dollar is definitely one start symbol, or dollar is definitely there in the start symbol A's follow set, and then we have to see what can follow. Like here, if you apply, if you look into this rule, it says that whatever A, so A is followed by Y. So, Y will definitely come in the follow of A. Then what is the follow of B? So, follow of B is whatever is in first of C can be in follow of B. So, first of C contains x and y. So, follow of B will have x and y in it, and follow of C. So, C may be followed by x. So, this is there, okay. And from this rule B producing y A, whatever is in follow of A will be in follow of B. So, that way, so whatever this B, so whatever is in follow of B will be in follow of A. Like whenever I have got a rule like A producing alpha B, then whatever is in follow of A will be in follow of B, because if there is a string where I have got A followed by some terminal symbol say A, so at the next step I can replace it by alpha B A. So, whatever is in follow of A is in can be in follow of B. So, follow of A has got dollar and so follow of A has got here you see that follow of B, whatever is in follow of B can be in follow of A if we go by this rule. So, follow of B has got x and y. So, that will come to follow of A also. So, x will also be added here. So, this is the situation. So, I have computed the first and follow sets. Now, after computing the first and follow sets, I have to try to construct the LL1 parsing table. So, for the LL1 parsing table construction, do it like this. So, I have got the non terminals A, B and C, and then I have got the terminal symbols x, y and dollar. Now, we come to the first rule A producing BCX. So, I have to see what is the first of BCX. So, first of BCX is equal to first of B, first of B is y. So, I will have this rule A producing BCX added here, and then so that will be added here. Then coming to the second rule A producing y. So, it says that in the first of y this rule should be added. So, first of y contains y. So, this rule will be, so this rule will also be added here A producing y, fine. Then whatever from the second rule we see that B producing y A. So, this first of y A contains y. So, B y I will have this rule B producing y A. So, this will be added here. Now, I have a rule B producing epsilon. So, if B producing epsilon is there, so whatever is in follow of B, there this rule has to be added. So, follow of B contains x and y. So, follow of B will have B producing epsilon. So, this rule will be added here as well as this rule should be added here B producing epsilon. Then I will have this third case C producing A y. So, whatever is in first of A y, so first of A y is equal to first of A, that is y and x. So, there I will be adding this rule. So, C producing A y and C producing A y. So, these two are added, and there is a rule C producing x. So, it says that this rule should be added here also C producing x. Okay. So, you see that after constructing this table, so we see that several entries are multiply defined. So, this is a there are 2 rules here, 2 rules here and 2 rules here. So, if you make a predictive parser, so parser cannot take a decision like which rule to follow for doing the parsing the string, which rule should be followed. So, naturally, so this grammar is not LL1. So, this grammar is not LL1. So, this is the decision that we have for this. That way, so you can always try to do you can try to check whether a grammar is LL1 or not by constructing the corresponding predictive parsing table. Next, we take another example where we try to see whether a given grammar is LL1 or not, and this third example. So, this is the grammar is like this it has got a set of rule. So, again the question is same, check if the grammar is LL1. If the grammar is LL1. So, the rule is given, the production rules are like this: A producing B A, then A producing ampersand B A or epsilon, then B producing true or false. Okay. So, here this is something like a Boolean grammar, and here all these are all these are terminal symbols, this ampersand, then true, false. So, these are all terminal symbols, and E, B and A, they are the non-terminal symbols. Again, if you try to check whether this grammar is LL1, first of all the grammar does not have any left recursion. So, I do not need to do a left recursion removal, but next step is to find the first and follow sets and try to construct the corresponding table. So, if I try to construct, so the first and follow sets, so first of E, then first of B, then first of A, then follow of E, follow of A and follow of B. So, these are to be computed. Fine. Now, first of E, what is first of E? So, first of E is same as first of B, and first of B contain true, false. So, this first of B has got true and false. So, first of E will also have true and false. And what is first of A? First of A is ampersand. So, first of A contains ampersand. So, this is the thing about this first set. Now, what about the follow set? Follow of E, since E is the start symbol of the grammar. So, dollar is definitely there in the follow set. Now, I have got this E producing B A, that means whatever is in first of A will be in follow of B. So, first of A has got ampersand. So, that will come to follow of B. So, follow of B contains ampersand, and then here in this rule E producing B A. So, this A can be replaced by epsilon. So, whatever is in follow of E can be in follow of B. So, follow of E contains dollar. So, this dollar will come in the follow of B. And what about follow of A? So, follow of A by the same rule, whatever is in follow of E will be in follow of A. So, follow of E has got dollar. So, this dollar is there in the follow of A. Okay. So, this way you can construct the first and follow sets for the grammar. So, for the symbols, non-terminal symbols. So, you can check that there is no more no more symbol that we can add to the first and follow sets. So, next we try to construct the corresponding parsing table to see whether there are duplicate entries. Okay. So, it is like this. So, we have got the symbols non-terminals E, A and B, and the terminal symbols ampersand, true, false and dollar. Now, this first rule tells me that whatever is in first of B, there I have to add E producing B A. So, first of B contains true and false. So, there I should add E producing B A, E producing B A. So, they are added. Now, coming to the second rule, it says A producing ampersand B A. So, first of ampersand B A contains ampersand. So, there I should add this rule that A producing ampersand B A. So, this is added. Now, the second part A producing epsilon. So, since it is epsilon, so I have to check the follow of A, and whatever is in follow of A, there I have to add A producing epsilon. So, follow of A contains dollar. So, this A producing epsilon should be added there. So, A producing epsilon is added. Now, coming to the third rule, B producing true or false. So, I will be adding B producing true at this point and B producing false at this point. So, all the rules have been taken into consideration. So, my table construction is over. So, whatever entries are not defined, they are all error entries. So, and you see that there is no duplicate entry. So, this is also, this is a grammar is LL1. So, we can conclude that the grammar is LL1 grammar. Okay. So, next we will be looking into another example of a bigger grammar, for which we try to construct the LL1 parsing table. So, this is basically the grammar for Boolean expression. This is the grammar for Boolean expression. And we have to construct the corresponding LL1 parsing table. So, the grammar given is like this: R producing R plus T or T, now T producing T F or F, then F producing F star P or P, P producing within bracket R or A or B. This is some sort of Boolean expression. So, it is a modified version of that. So, it is not truly a Boolean expression, but some sort of Boolean expression. So, if we eliminate this left, so first step for getting the corresponding LL1 parser is to remove the left recursion. So, if you remove the left recursion, so this grammar can be converted into something like this, that R producing T R dash, then R dash producing T R dash or epsilon, then so there should be a plus here, plus T R dash or epsilon, then this T producing F T dash, and then T dash producing F T dash or epsilon. Then this F giving P F dash and F dash giving star P F dash or epsilon, and then this P giving within bracket R or A or B. So, this is the after eliminating left recursion. So, this is the grammar. Now, next part is to compute the first and follow sets. So, the first set can be computed first of R, first of T, okay, first of we go in a order, first of R, first of R dash, then first of T, then first of T dash, then first of F, then first of F dash and first of P. Okay. So, first of R, so from the, so first of P is this open parenthesis A B. So, this is open parenthesis A B. So, this is the first of P, then first of P dash F dash is this star from this rule. So, from this one F producing P F dash. So, whatever is in first of P is in first of F. So, this one contains open parenthesis A B. Now, coming to this one, whatever is in first of P is in first of T dash. So, first of T dash also contains open parenthesis A B, and then from this rule, so whatever is in first of A, so that is done. So, this is, so whatever is in first of F will be in the first of T. So, again open parenthesis A B. So, they will be in the first of T. Then from this rule R dash producing this. So, first of R dash contains plus, first of this plus T R dash contains plus. So, this is plus only, and from R it says whatever is in first of T will be in first of R. So, first of T contains open parenthesis A B. So, they are included here. So, we will continue with this in the next class.